Hello, Mr. Adam.
Hello, Mido.
Today we will continue our discussion of the sea. Is not it?
Yes, let's start now. Tides. Tides are the regular rise and fall in water level experienced by seas and oceans in response to the gravitational influences of the moon and the sun, and the effects of the Earth's rotation. During each tidal cycle, at any given place the water rises to a maximum height known as high tide, before upping away again to the minimum low tide level. As the water recedes, it uncovers more and more of the freshwater, also known as the intertidal zone. The difference in height between the high tide and low tide is known as the tidal range or tidal amplitude. Most places experience 2 high tides each day, occurring at intervals of about 12 hours and 25 minutes. This is half the 24 hours and 50-minute period that it takes for the Earth to make a complete revolution and return the moon to its previous position relative to an observer. The moon's mass is some 27 million times smaller than the sun, but it is 400 times closer to the Earth. Tidal force or tide-raising force decreases rapidly with distance, so the moon has more than twice as great an effect on tides as the sun. A bulge is formed in the ocean at the place where the Earth is closest to the moon, because it is also where the effect of the moon's gravity is stronger. On the opposite side of the Earth, the lunar force is at its weakest, and this causes another bulge to form. As the moon rotates around the Earth, so do these ocean bulges move around the Earth. The gravitational attraction of the sun is also working on the seas, but its effect on tides is less powerful than that of the moon, and when the sun, moon and Earth are all aligned, full moon and new moon, the combined effect results in the high spring tides. In contrast, when the sun is at 90 degrees from the moon as viewed from Earth, the combined gravitational effect on tides is less, causing the lower neap tides. A storm surge can occur when high winds pile water up against the coast in a shallow area, and this, coupled with a low-pressure system, can raise the surface of the sea at high tide dramatically. Ocean basins. The Earth is composed of a magnetic central core, a mostly liquid mantle, and a hard rigid outer shell, or lithosphere, which is composed of the Earth's rocky crust and the deeper mostly solid outer layer of the mantle. On land the crust is known as the continental crust, while under the sea it is known as the oceanic crust. The latter is composed of relatively dense basalt and is some 5 to 10 kilometers, 3 to 6 miles, thick. The relatively thin lithosphere floats on the weaker and hotter mantle below and is fractured into a number of tectonic plates. In mid-ocean, magma is constantly being thrust through the seabed between adjoining plates to form mid-oceanic ridges, and here convection currents within the mantle tend to drive the two plates apart. Parallel to these ridges and near the coasts, one oceanic plate may slide beneath another oceanic plate in a process known as subduction. Deep trenches are formed here, and the process is accompanied by friction as the plates grind together. The movement proceeds in jerks which cause earthquakes. Heat is produced and magma is forced up, creating underwater mountains, some of which may form chains of volcanic islands near to deep trenches. Near some of the boundaries between the land and sea, the slightly denser oceanic plates slide beneath the continental plates, and more subduction trenches are formed. As they grate together, the continental plates are deformed and buckle, causing mountain building and seismic activity. The Earth's deepest trench is the Mariana Trench, which extends for about 2,500 kilometers, 1,600 miles, across the seabed. It is near the Mariana Islands, a volcanic archipelago in the West Pacific. Its deepest point is 10.994 kilometers, nearly 7 miles, below the surface of the sea. Coasts. The zone where land meets sea is known as the coast, and the part between the lowest spring tides and the upper limit reached by splashing waves is the shore. A beach is the accumulation of sand or shingle on the shore. A headland is a point of land jutting out into the sea, and a larger promontory is known as a cape. The indentation of a coastline, especially between two headlands, is a bay. A small bay with a narrow inlet is a cove, and a large bay may be referred to as a gulf. coastlines are influenced by a number of factors, including the strength of the waves arriving on the shore, the gradient of the land margin, the composition and hardness of the coastal rock, the inclination of the offshore slope, and the changes of the level of the land due to local uplift or submergence. Normally, waves roll towards the shore at the rate of 6 to 8 per minute, and these are known as constructive waves as they tend to move material up the beach and have little erosive effect. Storm waves arrive on shore in rapid succession and are known as destructive waves as the swash moves beach material seawards. Under their influence, the sand and shingle on the beach is ground together and abraded. Around high tide, the power of a storm wave impacting on the foot of a cliff has a shattering effect as air in cracks and crevices is compressed and then expands rapidly with release of pressure. At the same time, sand and pebbles have an erosive effect as they are thrown against the rocks. This tends to undercut the cliff, and normal weathering processes such as the action of frost follows, causing further destruction. Gradually, a wave-cut platform develops at the foot of the cliff, and this has a protective effect, reducing further wave erosion. Material worn from the margins of the land eventually ends up in the sea. Here it is subject to attrition as currents flowing parallel to the coast scour out channels and transport sand and pebbles away from their place of origin. Sediment carried to the sea by rivers settles on the seabed, causing deltas to form in estuaries. All these materials move back and forth under the influence of waves, tides and currents. 66. Dredging removes material and deepens channels but may have unexpected effects elsewhere on the coastline. Governments make efforts to prevent flooding of the land by the building of breakwaters, sowels, dikes and levees and other sea defenses. For instance, the Thames Barrier is designed to protect London from a storm surge. 68. While the failure of the dikes and levees around New Orleans during Hurricane Katrina created a humanitarian crisis in the United States. Water cycle. The sea plays a part in the water or hydrological cycle, in which water evaporates from the ocean, travels through the atmosphere as vapor, condenses, falls as rain or snow, thereby sustaining life on land, and largely returns to the sea. Even in the Atacama Desert, where little rain ever falls, dense clouds of fog known as the Comanchaca blow in from the sea and support plant life. In Central Asia and other large land masses, there are endorheic basins which have no outlet to the sea, separated from the ocean by mountains or other natural geologic features that prevent the water draining away. The Caspian Sea is the largest one of these. Its main inflow is from the river Volga. There is no outflow and the evaporation of water makes it saline as dissolved minerals accumulate. The Aral Sea in Kazakhstan and Uzbekistan, and Pyramid Lake in the western United States are further examples of large, inland saline water bodies without drainage. Some endorheic lakes are less salty, but all are sensitive to variations in the quality of the inflowing water.